In this video, I'm going to reduce heap allocations a little for my website. The website is right here, like it's just server-side rendered pages made with my own web framework. And the projects on the website are defined using my custom format, and this is the representation of them in memory. I can show the format from tests, like here's the minimal example, and more like all features of projects in this example. So what I'm going to be doing is, as you can see, there are vec, and vec, and all of these are heap allocations, and that's like not cool. It's unnecessary. I'm going to be changing the links and the stack today, but I'm gonna leave the description alone because it can just be turned into one pointer, one reference, and so I'm gonna leave that for later. Let's actually put this last. So what we want to do is turn the links. So we're gonna turn the vec. I cannot not use computer today, into just an array. So it's not going to be a slice, it's going to be an array, and it's going to be an array of, like, I thought about it, and realistically I'm probably not going to have more than 8 links total. But we can't just do this, and so I think it's going to be an option. The array of options of pointers. And the same thing for the stack, but the stack likely needs like 16 places. Little bit more. So now the structure definition has just one vec, which is also going to disappear in the future, and these are just arrays, and they're small enough that we shouldn't care about unused space in them. It's better than vecs anyways. And so what happens is that now all code breaks. We can see that cargo watch, it's not cargo watch, it's just watch exec utility that just executes cargo run when these kind of files change. Sorry. And so what we want to do is now fix everything. The parser is not great, and it's probably bad, but that's what we are gonna do anyways. Now, it supports comments, and the comments are also supported in the description, and they're ignored right now. But I'm probably gonna do the one string slice anyways, and not support comments in the description. So everything that's description should be contiguous, and it should just be some text that is parsed later. So now we're just gonna see what breaks and what we can do about that. Let's actually probably define some interface first. Let's do impl project. because we can't use links and stack as is anymore. It's not very convenient or ergonomic. And so we're gonna do just like some helper functions. And what we want is function that it's not a function, it's a method that has a reference to itself, and it returns an iterator where items are tuples of string slices, which are the links themselves. It's just name and URL. I decided to use a tuple because it's clear enough and it doesn't require making another struct. And so self links, it's probably gonna be iter and filter, where we are filtering for there probably is a helper function that, so a slice iter and there has to be a thing that, you know, does the filtering automatically, because this writing this is not very probably cool, because filter there's filter map and we want filter map, but this is redundant and there should be a method for that, I think. Maybe not. So what's the problem here? I messed up delimiters. Yeah, I didn't use, I used extra bracket. So we were expected an option. We want iter copied, because those are just pointers. Copying pointers is fine. Maybe cargo clippy would help, but it's probably gonna say like 200 warnings. No, it's just 6. Oh, it cannot compile. That's why we cannot even use clippy. But we're just gonna leave it like that for now. And the same thing for the stack. We're gonna do the same thing for the stack. Self.stack. And the item this time is just gonna be a string slice. Now we also want probably the amount of links. Then it's probably gonna be links and links len. I'm gonna name it like that, and it's gonna be usize, and we're gonna do self.links iter filter link is sum and count. I'm just gonna do copied here because it's the same thing. And I also want the stack len. So we'll use the ergonomics of vec, and there's probably a better way to do this, but that's fine with me. So this is not a stack, it's a technology, that's what it's called. And so now we have the helper methods, and I'm just gonna go around and fix all the call sites. So here we have, we're checking if we have any links. It probably needs to be more than 0. It seems more readable this way. Now the links is just the links method. Actually, it has to be a pub method. And let's continue fixing. If project.linkslen is more than 0, and we want project.links like this, we're gonna fix the stack later. Here we also have the thing where we create a project. That's gonna be fixed later also. The tests are also gonna be fixed later. And that was it. Now the stack. Go to all references. And so now here we just want the stack iterator, and we want it peekable. Here we also want the iter. And all the other usages are from the implementation and the tests. So we fixed it around the code base. That's not what I wanted to open. So we want the project parser, and I want that as the first thing. Now I'm going to be fixing, the actual parser. There's probably not much fixing is going to be needed. So what we want to do is in the project body state, we want the vec also to be an array of, this is going to be 8 links, and this is going to be 16 string slices. So hopefully you see the problem. 16 and 8 is hard-coded in 2 places, and these are options actually. So we probably want them as constants defined somewhere. Also, we want to know probably the amount of links and the amount of technologies, but it can also be done with an iterator. And we don't have to remember because there's so little, such a small amount of items that it doesn't matter. Now, when we create the state, when we initialize it here, we want to create the new arrays, and I actually don't know how to do that. So can we just do the non like 16 and 8 times? And why can't we do that? Yeah, we can do that. And now we initialized our storage. So when populating the storage, we want to use not actually push, but overriding nons into sums. Alright, so what I want to do now, I'm not like thinking well. So here we parsed link. Yeah, I wanted to know, so the errors are not handled well right now. Let's actually create another two error variants. Too many links and too many technologies. I will define the error for error. And I will define also display, but I will do this at the end as a refactoring thing. So now we can try and parse our links first. So what we want to do is try and find an empty slot where we want the links, which is an array of options. In it we want to find, so we want to probably to do iter and enumerate. It's probably going to be itermute, and we want to find slot that is empty. And so this is going to be an optional thing, and let's say we want to find that, or else we want to return an error that is too many links. We couldn't find an empty slot in our links array, and that's too many links to support. Too many links to add, and it's more than we support. And then empty slot, we just want to have it as some link. Well, what I want to do now, I'm not sure if I can do that. How can I find a mutable slot? Because this empty slot, it should work. So I want to just dereference that. Yeah, I just stopped thinking there for a while, I guess. Now for the stack is quite similar situation, but we just cannot define stack twice. The format is as follows. We can have many links, and each link is name and URL delimited by a semicolon. And for the stack, it's just one entry, and each technology is delimited by a semicolon and a space. And so we just want to check if stack, any of them have values. So what we want to do now is populate the stack with our things, with our technologies. So the technologies are just the string references, and for each slot we want to put the technology, and we're just gonna do the enumerate and do the for loop over this enumerated iterator. But what I'm gonna do here, if technology is equal or greater, actually greater or equal, then our 16 slots, we want to return an error now. Too many technologies. And it's not technologies, it's a stack. And I did it like a weird thing where I didn't think again. I didn't sleep enough today. I just slept for 5 hours because my neighbors started drilling holes in their walls again. I don't know why they're doing that. But now we actually have, I guess, something working. If I refresh the page, I have all my projects. The tests are broken though. Let's fix the existing test and then add more for our new errors. So what we have here is the links are, well, not really well working. So let's just turn all of these. Why am I like, I don't know what's happening today. Turn all of these into options and see that it actually compiles now. And project stack is similar. We're just gonna turn everything into option. And have the project stack. Just check the first 3 things as a slice. I could check that that everything else is none. So let's actually do that. Assert that project links let's do the slice from third and further, and all of the things are empty. It's not is empty, actually, it's none. And let's see if that compiles. That compiles. And now we can also do that with the stack. Now we can run the tests. Cargo test. So that didn't work. So it says on line 242, it doesn't work. And that's why we just want to get our length and compare it to 0. And that's gonna do the thing. Because the code here was turning an array of fixed size, like 8 and 16 in this case, into a slice. And those had also fixed sizes that are not 0 and they were not empty. And so that was the problem. Now we wanna actually test parsing where we have too many things. So let's yoink this part of this test. Too many. I'm just gonna call it too many. And so what we want here is we want to have a project where we're going to define something here, and then it's actually going to be an error. So let's parse maximum. The maximum amount of things. And then we will check that it has 8 links and 16 technologies. So we want to have 1, 2, 3, 4, 5, 6, 7, 8. And then we want to have the stack that is 1, 2, 3, 4, 5, 6, 7, 8. And that again. This is going to be 16 technologies. So I'll run the test and I'll filter for the word to. And here we have actually this working. Now we want to have actually too many things. Let's have the project, but we will duplicate one link again. And we will do, I think there is assert matches now, but I have to import that. So we're gonna do assert matches, and we want to match that to an error that is too many links. Let's see what the compiler says. Consider importing this macro, use std assert matches. So let's go to the top of the tests. Use std assert matches. Now it doesn't want to do anything. That's because project doesn't implement debug. I can do that. It's not a problem. And it actually now compiles. And the test works also. And now we want to do assert matches where we don't have too many links, but we have a 17th technology that doesn't fit. And the error is gonna be not too many links, but actually too many technologies. Let's try and run the test. It's gonna compile the thing. And here we go. The tests are now working for our limited number of links and stack. So there is some, what is that, warning? A dead code method. I guess I could just remove that if I don't use it. Let's see where I use the stack. Yeah, I can use the stack len here, and we can check if that's more than 0. This is gonna be more clear what's happening, and it's gonna eliminate that code, and I'm actually gonna use the thing like it was intended to be used. Yeah. Now the error is a problem here. First of all, it's written in a poor way where I just use strings, but that's gonna be fixed later. First, let's actually implement the error traits for it. So we want the source for the error, and that's just gonna return none, because these errors don't have sources. But display std fmt display, we want the fmt function, fmt method, and that is going to actually do the thing. We're gonna match on self, and we have 3 variants. Let's use the vim thing and use the vim thing again. It's control V, $, capital A, and then we write the thing, and we use the right macro. Now we want to write the message, and this is not the static str, but it's actually a message, and we're just gonna write the message to the error and just state the facts for these errors. And this is the normal now error implementation, and we stopped getting the warning that the error message is not used because it's actually used now. It can be printed on error. We can do the cargo check. The functions in these functions are not used, and that's fine. I'm not gonna do cargo clippy. I'm actually gonna do cargo clippy. That's not gonna be pretty. Let's see what it says. It says a lot. So this is content parser, CV, project parser. Yeah, there it is. I called it, and there is a method for it, flatten. And let's use that. So it shouldn't be a filter map, it should be flatten. And here also and now we can also do the flatten thing here. And now it's more clean. Let's look at the flatten documentation. This is useful when you have an iterator of iterators or an iterator of things that can be turned into iterators, and you want to remove level of indirection. Well, that's not really the use case. We're using it here. But let's see what Clippy says now. Nothing related actually to this module that we refactored today. Let's run cargo test again to test our new implementation, and that also worked. And the website also works and displays all my projects as it was before, but instead of vex, it's pre-allocated arrays. So I thought I didn't care, but it's actually not very hard to do. we can... So the problem with this one, with this implementation of these four, methods, is that they walk the whole array each time, and we don't have to do that because we know that we have some values and then some slots after that. And what we can do is we can use like a take while and do that instead. So we want to do take while slot is sum, and this is gonna optimize the thing, and it's not gonna walk the whole thing every time. Well, I hope at least. I hope it works like that. And we can run the tests and see that it actually passes now, but it doesn't walk the whole 24 things for each project every time. It stops when there are no more things to iterate. When values stop, we don't walk the empty slots. And so the site still works. They just wanted to cover that. And yeah, it might not be the best way to do the thing, or it might not be the most ergonomic way, but it's just what I came up with on the spot. And it works, and it eliminates heap allocations. So yeah, that's it.